Welcome to the third video of the Introduction in R. In this video we talk about descriptive analysis. Like and subscribe, and I hope you learned something for your statistical journey. First we remove all the stuff in our environment down here. Therefore we use the well-known remove function, and then we need some datasets which we can work with. And so we use the install packages function to get the package datasets. Then we will use this, run it. I already ran it, so I will not do it here. And I will just use the library function. And then we perhaps want to know what's inside datasets. And so we use the question mark datasets. And then we can see a package which contains a variety of datasets. And it also gives us the tip to use this function to see what's inside. Inside datasets we have this particular datasets. And what we will use. You can use whatever you want, and I will use cars and ESOF. Then let's start. So first we build objects, and the first object is the one with which contains cars, and the second object is the two which contain ESOF. Then we start with the first look on the data, which is always useful to get to know the data, what is inside it, what we can make out of it, and how do particular variables behave. So we have the first view. That will open a window here. Then we can see here we have the column speed and the column distance, which are the several variables of this dataset. You can plot it here. You can plot, for example, D1 and index speed. You can index with the $sign. And then you see the point graph of speed. Then you can also show distance, like the stopping distance. Then you can also plot distance against speed. And then you see the more speed a car has, the more distance it will use to stop the vehicle. And so you can also show like the probability density function. So if you want a video about this topic, I can make a video, just write in the comments. Then we can see, based on the hist function, the probability density function of speed. And we can also do the same for distance. So with the next functions, we can look at how many observations we have, how many columns, how many variables. So therefore we can use the dim function. With the dim function we can see in the first value here is the rows, so the observations, and the second one is the variables, the count of the variables. We have 2 variables and 50 observations. We can also show this separately with n-col and n-row. So then we can also show what is the class of my particular object. The class of my particular object is data frame. We can also show the class of the particular variable, which is in speed. So speed is numeric. And we can also look at the structure of our data. So we can see we have 50 observations based on 2 variables, and these are the class. This is the class of each variable. These are the occurrences of each variable. So the first car has a speed of 4 and a distance of stopping of 2. So then we can also look at the call names, or the names of the rows. And the row names are just like the numbers. And we can also use dim names to show both in one function. Then we can also index it. And we can see just the row names if we index with 1. Or we can see the just the row names and the row name for the row 3. And the row name for the row 3 is 3. We can use the max function to show the maximum value of each particular variable. Then we can also use the min function to see what is the minimum value of each variable. So we can use the range function. The range function will show the min and the max value of our particular variable. The length function will show the length of our particular variable. The variable, if you want to know the observations of a particular vector, it's recommended to use length. And if you want to see the observations of a particular matrix, you can use nrow. Or if you have a data frame, you also can use nrow. Then we want help for the range function, and we see range returns a vector containing the minimum and maximum of all the given arguments. Then we can also calculate like the range in between, so which is like the difference between like the minimum and the maximum. And therefore we can use the absolute function. The absolute function will give us the absolute value. And then we can show rs is like 21, which is correct. Then we can also look at the interquartile range, which is 3. Interquartile range is the difference between the 25% quartile and the 75 quartile. Then we can look at the quantile of speed, and you see we have done the right computation. So you can also do it manually, and then we have this object generated, and it has the value 7, but the name isn't right. This isn't a 25 quantile, it is just the interquartile range. And so we want to adjust the name, and we use the function names, which will point out the name of IQRS, and then we put in the name IQ for speed, interquartile range for speed. And then we adjust it, and now we use this object, and we see the name has changed. Perfect. We also can calculate the median. Then next we show the boxplot. If you're not familiar with Boxplot, I can make a separate video for it. Just write down in the comments. So Boxplot, we make the question mark in front of it, and we can see produce a box and whisker plot of the given values. We can also group them, but this is something for the later sessions. So then we can make a box plot and save it as an object. We can also look at the stats of this box plot, and we see all the values which are used in this box plot to generate it. We can also ask how many observations. If we index n, then we can also do it for distance, and it will look like that. So, and then we can go on and use the table function. The table function will show all the occurrences of a particular variable. For example, we have the age group, and in the age group we have 15 in the range of 25 to 34. So then we can do the same for the alcoholic group, and we can do the same for the tobacco group. Then we can also look at the cases we have. This should be like the cancer cases, how many people got cancer. And then we can also see the control group. And if we want to look at it a little bit more handy, more nicely visualized, then we can use the pie chart. The pie chart will generate this, the pie function will generate this pie chart. But always keep in mind that you have to use the table function before it, so it knows which group has this many occurrences. can also use the summary function. The summary function will give us a look on some computation which you can do, which is the median and the mean, for example. But we also can do it ourselves, and if we calculate the mean of D1, but D1 is an object which is of the class data frame. So this can be like computed, because D1 isn't a numeric variable. But we can use the function callMeans, which computes the means of every column. So it takes the variable speed and makes a mean, it takes the variable distance and makes a mean. This works. We can also use variance, and here we can print out the covariance matrix. Then we can make the mean for each particular variable, like for speed and for distance, and also for the variance. So then we can use the attach and detach function. I don't recommend using those, but I will show you closely what you can do with it. So the idea behind attach and detach is you don't have to index anymore. But the problem is if you use this particular function and in some later case you want to use a different object, then perhaps it can make some problems. Because if you don't detach it and want to use some variable which is speed, then it will perhaps not recognize the vector and just the objects out of D1. So I prefer indexing with the objects and don't to attach and detach. So we attach D1, and so we don't have to index anymore, so we can move very fast. So we can just write distance and calculate the mean, and we can just write speed and calculate the mean. And the variance. So we can also c-bind it first, so we can column bind this two variables, and then we have a matrix, and then out of that we can make the covariance matrix. And then we have to detach it. So this is how we generate a matrix artificial. So we generate a matrix with the function matrix. We have the data, and this is the input we will give the matrix. Then we say we want 2 rows and 2 columns, and we want it to filled by rows. So first I will fill in the first row and then the second row. If it's false, then it will be filled in by columns. So first the first column and then the second column. And then you can also give it the names, like I like the R1 and R2. So now we generate M1. M1 looks like that. And we see here we have the particular matrix with the row names R1 and R2. We also want the call names, so we use S1 and S2. And then we have a matrix with nice names. We can also generate this matrix, and we can use the solve function here to make the inverse of this particular matrix, which is pretty nice. And it will look like that. Perfect. So if you want to generate some vectors, we can use the sample function, and then we can c-bind those vectors to a matrix, or r-bind to a matrix. So r-bind will bind by rows, and c-bind will bind by columns. So, but we have to keep in mind, if we mix the data together in a matrix and we put in different data types, then we have a problem. Because if we put in a numeric data type and a character data type, in the end we get all characters in our matrix. So if we want to put different data types, we better use data frames. If we want to put in just one data type, we can also use matrix. This you have to keep in mind because you can't make computations out of these values. So you can't make the mean of the column too. So another nice thing is matrix is two-dimensional, arrays are three-dimensional, and vectors are one-dimensional. If you build an array, we have to say how many rows, how many columns, and how many areas behind it. So we have 4 rows, 4 columns, and 4 areas behind it. And it will look like that. Yeah. And then we show how to index. So perhaps we just want to see the 4 rows of every matrix. Then we can also use the columns and indicate all the second columns. We can also use this and show just the last matrix in the last area. Then we can just index one value, which is the 36th value, and then we can also use like index 100, but we don't have a 100 value, so it just gives us an A, which is not available. So, and then we can index like the 4th row, the first column, and the first area. And then we get the value 4. Now we have a look at what we've done today. So we've used install packages function to get the datasets package, and we also can update packages with update packages. Then we used the library function to get it out of the shelf. Then we had a nice overview with the function view. Then we plotted in a point graph. Then we did the probability density function with hist, which shows us the histogram. Then we used the dim function to show the dimensions of our particular dataset. Then we used the n:\n function to show it separately. Then we used the class function to get to know the class of our object or of our variables. Then we used the structure function to get to know the structure of our data. Then the dim names and row names and call names to show the names of all the dimensions. Names mostly shows us the column name. And with max and min, we can show the minimum and the maximum. With range, we can show maximum and minimum in one vector. Then we used the absolute value with the function abs. Then we used the interquartile range. We also showed the quantile of a variable, and then we showed the boxplot, the table function to show the occurrences in a variable, the pi function to make it better visualized what we see in table, the mean to show what is the mean of our variable, and call means to show the mean of every column, and then variance with the var function. So this is for today's lesson. Please like if you learned something or you liked the video, or perhaps it's better if you like it and you learn something, and please subscribe to the channel, and I will keep you updated on next videos, and see you soon.